In late 2023, something went wrong with the most distant machine humanity has ever built. For weeks, it had been sending data home the way it always had, faithfully, across billions of miles of empty space. Then the data stopped making sense. The signal was still arriving. The spacecraft was still alive. But what it was saying had turned into nonsense, an endless stream of garbled code that no one at NASA could read. The engineers stared at it and felt something close to grief. After 46 years, it looked like Voyager 1 was finally dying. And dying mid-sentence, with whatever it had been trying to tell us locked inside a broken machine 15 billion miles away. That is where this story really starts. Not with a launch, not with a triumph, but with a small, dying spacecraft that had something to say, and very nearly lost the ability to say it. Because once the engineers managed to save it, and they did save it, in one of the strangest rescues in the history of spaceflight, the thing it went right back to telling us turned out to be something that should be making headlines on every continent. It is not. And by the end of this, you may find that strange too. Let us start with the machine itself, because almost nothing about it makes sense by modern standards. Voyager 1 launched on September 5th, 1977, from Cape Canaveral in Florida. It was built with the technology of the early 1970s. The computers on board have less memory between all of them than a single modern greeting card that plays a song. It was designed for a 4-year mission. Fly past Jupiter, fly past Saturn, send back some photographs, and then quietly shut down. That was the entire plan. A short trip to the outer planets and a dignified end. It did not end. It passed Jupiter in 1979 and discovered that one of its moons had erupting volcanoes, something no one had imagined. It passed Saturn in 1980. And then, instead of going dark, it just kept flying, faster and faster, hurled outward by the gravity of the giant planets like a stone from a sling. It crossed the orbit of Pluto. It crossed regions of the solar system that had only ever existed in equations. And in August of 2012, it did something no object, made by human hands, had ever done. It crossed the Heliopause and entered interstellar space, the true emptiness between the stars. To understand why that matters, you have to understand what the Heliopause is. Our sun does not just sit there giving off light. It blows. It pours out a constant wind of charged particles in every direction, and that wind inflates an enormous bubble around the entire solar system. Every planet, every moon, every comet, everything you have ever known or touched or loved, sits inside that bubble. The heliopause is the wall of it. The place far past the last planet, where the sun's wind finally runs out of strength and presses up against the gas of the wider galaxy. Cross that wall and you are no longer inside the sun's domain. You are in interstellar space, surrounded by material that came from other stars, stars that lived and died before our sun was ever born. Voyager 1 is out there now. It is the first thing we ever made that left home completely. And it is still talking. Which brings us back to the rescue. When that broken chip turned Voyager's signal to gibberish in late 2023, the engineers at NASA's Jet Propulsion Laboratory faced a problem with no precedent. They could not send a technician. They could not swap a part. Everything had to be done by radio, and the radio took its time. At that distance, a command from Earth needs around 22 hours just to arrive. Then the spacecraft has to answer, and that answer needs another 22 hours to come back. So every single thing they tried, every test, every guess, every small fix, cost them roughly 2 days before they even knew if it had worked. Imagine trying to repair a computer by mail, where each letter takes a day to arrive, and the computer is older than most of the people working on it. And there is no manual because nobody ever planned for this. It took months, They eventually found the cause, and it was almost absurdly small. A single memory chip, one tiny piece of 1970s hardware, had worn out after nearly half a century of being bombarded by cosmic radiation. One chip, the size of a fingernail, sitting 15 billion miles away, had scrambled everything. So the engineers did something remarkable. They took the broken section of code, broke it into pieces, and tucked those pieces into other parts of the spacecraft's memory that still worked, rewriting how a dying computer thinks across a 2-day delay, using a programming language older than most software engineers alive today. And it worked. In 2024, Voyager 1 started speaking clearly again. The first full thing it said, once it could, was the very thing it had been saying before it nearly died. A faint, steady signal that nobody can fully explain. Here is that signal. Since 2017, one of Voyager's instruments, the part of it that listens to the plasma it travels through, has been picking up a faint, continuous hum, a narrow, steady tone in the gas between the stars. And according to the textbooks, the older models of how interstellar space behaves, that hum should not be there. Not like this. It is not a one-time blip. It is not a glitch in an old machine. It has been there year after year, measured continuously across a stretch of space more than 930 million miles long. To put that in plain terms, the distance from the Earth to the Sun is about 93 million miles. Voyager has been hearing this same unexplained tone across 10 times that distance, and counting. That is not an error. Something out there is real and steady and structured, and we did not predict it. Researchers published their findings in the journal Nature Astronomy, and the conclusion was quietly enormous. The space between the stars is not what we thought it was. We had pictured it as a near-perfect emptiness. A calm, uniform, dead vacuum. What Voyager is actually finding is the opposite. The interstellar medium is restless. It has waves and ripples and changes in density at every scale, from small pockets to structures larger than the distance between us and the Sun. It moves, it has texture. It is, in a physical sense, far more alive than anyone expected. And we are only learning this now because, for the first time in history, we finally have an instrument sitting inside it, instead of guessing from billions of miles away. Voyager is not just drifting through that space. It is taking its measure continuously as it goes. Now follow what that actually means. Because the consequence does not stay out there in the dark. It comes all the way back to you. That bubble the sun blows around us, the heliosphere, is not just a curiosity. It is a shield. It absorbs and deflects a large part of the cosmic radiation that constantly streams in from the rest of the galaxy. Radiation that would otherwise reach the surface of the Earth in far greater amounts. Life here grew up behind that shield. Now, think it through. If the space pressing against our bubble from the outside is more turbulent and more complicated than we believed, then the wall between us, and it is probably more complicated too. And if that wall is more dynamic than we thought, then the protection it gives us may not be as fixed and steady as we always assumed. Nobody is saying the shield is about to fail. That would be a lie, and the truth is dramatic enough on its own. What scientists are saying is more unsettling in a quieter way. They are saying, we may have been wrong about how stable it is. That the thing standing between life on this planet and the full force of the galaxy might shift and flex in ways we are only beginning to detect. And the only instrument anywhere that is measuring this from the inside is a 48-year-old machine, running on the last scraps of its power. There is one discovery from that boundary that people always ask about, and it deserves a straight answer because the obvious version of it is wrong. When Voyager crossed the Heliopause, it measured a temperature out there of somewhere between 30,000 and 50,000 Kelvin. In Fahrenheit, that is around 54,000 degrees. Hotter than the surface of the sun. Scientists started calling that region the Wall of Fire. And the question almost everyone asks next is the obvious one. How did a fragile 40-year-old spacecraft fly into something hotter than the surface of the sun without instantly melting? The answer is that temperature and heat are not the same thing, and this is the single most important misunderstanding in the whole story. We treat the two words as if they mean the same thing, because in daily life they almost do, but they do not. Temperature only tells you how fast the individual particles are moving. Heat tells you how much energy actually gets dumped into an object, and that depends on something temperature ignores entirely. How many particles there are. Out at the heliopause, the few particles that exist are moving incredibly fast, so the temperature is genuinely tens of thousands of degrees. But out there the gas is almost a perfect vacuum. The particles are so thinly spread that, even moving that fast, hardly any of them ever actually hit the spacecraft. So there is almost no energy being transferred. The temperature is staggering, but the heat is nearly nothing. The simplest way to feel this is to think about an oven and a sauna. The air in a hot oven can sit at 200 degrees, and you can reach your hand in for a moment without harm, because air is thin and carries little heat. But put your hand in water at half that temperature, and it will scald you instantly, because water is dense and packed with energy. Now go further. The wall of fire is thinner than the thinnest air you can imagine, almost nothing at all, with its few particles flung far apart. Each one is blisteringly hot, but there are so few of them, and so much empty space between them, that they cannot warm a passing object the way a real flame would. So Voyager flew straight through a region hotter than the face of the sun, and stayed frozen the entire time. The number is terrifying. The danger was almost none. Out there your instincts will lie to you. The wall of fire was not even the most surprising thing waiting at the boundary. That was the magnetism. For decades, the assumption was simple. The sun has its own magnetic field, which fills the bubble. The galaxy has its own magnetic field, which fills everything outside the bubble. And the two were supposed to point in completely different directions, so that crossing the heliopause would mean a sudden, dramatic shift in the magnetic readings. That shift was how everyone expected to confirm the crossing. But when Voyager went through, the magnetic field on the far side was lined up almost exactly with the field on the near side. The two were, in some way, connected. As if the sun's magnetic influence did not simply stop at the wall, but reached across it and merged with the galaxy beyond. Nobody had predicted that. And it points to something bigger than a single measurement. Our solar system is not a sealed, separate thing drifting through a void. It is plugged into the galaxy around it. It is part of a larger system that pushes back, that has its own weather and its own structure. We had been picturing our home as an island. It turns out to be more like a tide pool, connected to a much larger ocean we are only beginning to notice. Each of these findings feeds the next. The hum tells us the medium is alive. The alive medium tells us the boundary is complex. The complex boundary tells us our shield may be less stable than we thought. The magnetism tells us we are wired into the galaxy more directly than we believed. None of these were in the textbooks. All of them came from one spacecraft that, by every reasonable expectation, should have gone silent 4 decades ago. And that spacecraft is now running out of time. Voyager is powered by the slow heat of decaying plutonium, converted into a trickle of electricity. When it launched, that system produced about 470 watts. Today it makes barely half of that, and it loses close to 4 more watts every year, like a candle steadily burning down. To keep the most important instruments alive, the team has spent years shutting other systems off, one at a time. It is like a family in a freezing house, closing off the rooms they cannot afford to heat, retreating toward the last warm corner. In April of 2026, they switched off another science instrument, one that had been running almost continuously since 1977. Out of the 10 instruments the spacecraft carried at launch, 7 are already dark, and every shutdown is a gamble. Turn off the wrong heater, and a critical part could freeze and crack in the roughly -270-degree cold of deep space. And that would be the end, with no way to ever fix it. And yet the people who care for it refuse to let go. NASA engineers have been working on an experimental plan they nicknamed the Big Bang, a way to coax a little more usable power out of the aging spacecraft by changing how its remaining energy is shared. They are trying it on the safer candidate first, with tests running through the middle of 2026, hoping that if it works there, they can carry it across to Voyager 1. They are not confident, but they have learned not to bet against this machine, because the history of declaring it finished is a history of being wrong. The engineers doing this work are a different generation from the ones who built it. Some of them were not born when it launched. They have inherited an old, dying spacecraft from their predecessors, and they are nursing it through its last years across a gap of 2 days per conversation. And it is worth saying plainly, because the headlines almost never do. Voyager 1 is not out there alone. It has a twin. Voyager 2 launched 16 days before it, also in 1977, and took a longer road, becoming the only spacecraft in history to fly past all 4 giant planets, including Uranus and Neptune. Then in 2018, 6 years after its sibling, it crossed the Heliopause through a different part of the boundary entirely. So we do not have one set of sensors out there in the dark. We have 2, entering interstellar space from 2 different angles, each one checking and deepening what the other reports. When Voyager 2 made its crossing, it found the same surprises, the same hot, sharp, magnetically tangled boundary. 2 machines, launched within weeks of each other half a century ago, both now drifting beyond the edge of the sun's reach. But the 2 of them share a single hard fact. They are dying together. They were built at the same time, from the same parts, with the same slowly fading power source. Voyager 2 has already had instruments shut down to save its strength, just like its twin, and it faces the same final deadline. Both are expected to fall silent within the same handful of years, sometime in the early 2030s. So the comforting idea that losing one still leaves us the other does not really hold. We are not about to lose a single eye on interstellar space. We are about to lose both of them at almost the same moment. And when that happens, something quietly enormous ends with them. Right now, in 2026, the only working instruments humanity has anywhere in interstellar space are these 2 failing probes. Everything we know, first-hand, about the real conditions out there, we know because of them. When their power finally drops too low, the signals stop, the measurements stop. The continuous record they have been building, the only direct map we have ever had of the space between the stars, simply ends, and there is nothing ready to take their place. No replacement is flying. No replacement is even funded. And even if a new interstellar probe were approved and launched today, it would take 25 years or more just to reach the boundary Voyager already crossed. Which means a gap is coming, a long silence. Perhaps 3 decades or more in which humanity will have no presence at all in interstellar space. No live signal from the frontier, no way to keep reading the map. We will be left holding the questions Voyager raised, with no instrument out there to answer them. It is fair to be precise here, because the careful viewers always are, and they are right to push. Voyager has not truly left the solar system, not in every sense. What it crossed is the edge of the sun's wind. But the sun's gravity reaches much, much farther than its wind, all the way out to a distant shell of frozen comets called the Oort cloud. Voyager will not even reach the near edge of that shell for around 300 years, and it will not pass beyond it for tens of thousands. So in the truest sense, it has left the sun's weather, but it has not yet escaped the sun's pull. The edge of our home comes in Mutha, and Voyager has only crossed the first of them. But that first crossing alone has already forced us to rewrite what we thought we knew. Bolted to the side of this small, dying machine is a golden record, a gold-plated disc, put together by a team led by the astronomer Carl Sagan, holding greetings in 55 languages, the sound of rain and wind and ocean waves and human laughter, 90 minutes of music from cultures all over the world, and a map showing exactly where Earth is, drawn relative to nearby pulsars. It was meant for whatever might someday find it, somewhere in the galaxy long after we are gone. Some people think that map was a quiet act of arrogance, that posting our home address into the unknown could one day be a mistake we cannot take back. Others think it was the most hopeful thing our species has ever done. Tell us in the comments which side you land on, because there is no settled answer. Either way, that record will keep traveling long after the last instrument dies, long after the last person who worked on this mission is gone. In the deep future, when everything else we ever made has crumbled to dust, that disk, drifting silently between the stars, may be the last proof that we were ever here at all. And the strangest part is that we still do not know what the hum is. After all these years, the signal that nearly went to the grave with Voyager in 2023 still has two competing explanations, and scientists honestly cannot say which is correct. It might be the natural ringing of the plasma itself as it gets disturbed. Or it might be a subtler thing, the faint background noise of countless electrons in motion, secretly carrying information about the density of the gas. Telling the two apart would take either more data from Voyager, which is running out of power, or a future mission built for the job, which does not exist. So the honest situation right now is this. The only ears we have in the space between the stars are slowly going deaf, and the thing they have been straining to tell us for nearly a decade, we still cannot translate. That is not a tidy ending. It is not meant to be. The universe has never owed us a tidy ending. It has only ever been bigger and stranger and less predictable than we expect from inside our small, warm bubble. Voyager 1 was built by people using slide rules and paper in a decade before the personal computer and meant to last 5 years. Instead, it became the farthest thing our species has ever sent anywhere, the first to leave the sun's domain. And right now, in 2026, it is still out there in the dark, half broken, almost out of power, sending home a faint signal we cannot fully read, about a universe that keeps refusing to match our models. The signal is still arriving, stretched thin across more than 15 billion miles, slowed by nearly a full day of travel. It will keep arriving for just a few more years, and the only thing left to decide is whether we are paying close enough attention to hear it while we still can.